Nature of the roots. We call b squared minus 4ac the discriminant and use the Greek letter delta. So we have the formula delta is equal to b squared minus 4ac. Now to determine the nature of the roots, we think delta. If delta is greater than but equal to 0, you have real roots. If delta is less than 0, you have non-real roots. And if delta is equal to 0, you have equal roots. Then you have delta greater than 0, which is unequal real roots, which is 2 solutions. And then if delta is a perfect square, it's a rational root. And if delta is not a perfect square, it's an irrational root. Question A. For which values of m will the following question have real roots? So we think delta again. We have x squared plus 6x plus m equals to 0. So using the formula, delta is equal to b squared minus 4ac. We notice that 6 is the b, 1 is a, and m is c. From here, we'll simplify to 36 minus 4m. And then because we want real roots, we think delta needs to be greater than but equal to 0. So we'll take 36 minus 4m greater than but equal to 0. Negative 4m greater than but equal to negative 36. If I take the 36 over, divide both sides by a negative 4. So m needs to be less than but equal to 9 to have real roots. Number 2, 3x squared is equal to 2mx minus 3. That's not standard form, so we take everything over. 3x squared minus 2mx plus 3 is equal to 0. Using delta, so delta is equal to b squared minus 4ac, we substitute in. So we have negative 2m squared in brackets minus 4 times 3 times 3. Simplify, 4m squared minus 36. We need real roots, so delta needs to be greater than but equal to 0. 4m squared minus 36 is greater than but equal to 0. Factorize, we have 2m minus 6 in one bracket, 2m plus 6 in the other brackets, greater than or equal to 0. Because it's an inequality, we think critical values, so we have m is equal to 3 or m is equal to negative 3. Draw a sketch. Finally, our answer is m is less than but equal to negative 3 or m is greater than but equal to 3. B. For which values of m will the following equation have equal roots? M squared minus mx plus 2x plus 1 is equal to 0. Here we want the x to be factorized so we can get it in standard form. Now we can use delta is equal to b squared minus 4ac, where b is 2 minus m, a is 1, and c is 1. Simplify, we'll have delta equal to m squared minus 4m. For real roots, delta needs to be equal to 0, so we stay like this. M squared minus 4m equals to 0. Factorize, take a common factor of m, so we have m, and then in brackets m minus 4 equal to 0. M is equal to 0 or m is equal to 4. That's our final answer. C. For which values of m will the following equation have non-real roots? Again, this is not standard form, so we take over the 3x. We have x squared plus mx minus 3x plus 4 equals to 0. Again, simplify the x by factorizing. X squared plus m minus 3x plus 4 is equal to 0. So that will be our b value again. Delta is equal to b squared minus 4ac. Substitute in. M minus 3 is squared in brackets minus 4 times 1 times 4. Simplify. M squared minus 6m minus 7. So for non-real roots, we think delta needs to be less than 0. M squared minus 6m minus 7 is less than 0. Factorize, we have in one bracket m minus 7, the other bracket m plus 1 less than 0. Remember again, it's an inequality, so we'll have critical values, m is equal to 7 or m is equal to negative 1. Draw a sketch. Finally, m needs to be greater than negative 1, but also less than 7. And that is the end.